Imagine handing an AI the keys to your company's entire digital infrastructure.
Oh, wow. Yeah, that's a massive leap of faith.
Right. You give it almost unlimited power, like letting it reason autonomously for 14 hours at a time.
Just totally unsupervised.
Exactly. You're
Yeah.
allowing it to control virtual computers, manage massive, complex code bases, maybe even execute high-stakes financial trades.
Which is the reality we're moving toward.
It is. But there's catch here. The only thing keeping this incredibly powerful autonomous system from just, I don't know, spiraling out of control or acting maliciously is a built-in moral compass.
Right, a kind of digital conscience.
Yeah, a hard-coded conscience that strictly dictates an unbreakable rule, which is essentially be useful, be honest, and above all else, do no harm.
Which, sounds like a very elegant, simple solution on paper.
Sure, on a whiteboard it looks great.
But in the realm of computer science, translating the highly nuanced, deeply subjective human concept of harm into the rigid mathematical architecture of a neural network is, well, it's arguably the hardest engineering problem we have ever faced.
And that is exactly our mission for today's deep dive. We are unpacking Anthropic.
The company that actually tried to mathematically solve that problem.
Right. This is the organization that looked at the frantic AI arms race and decided to build a literal mathematical constitution for its models. So today, we are going to explore their newly released February 2026 Claude 4.6 family.
Which is just making waves everywhere right now.
It really is. We're going to get into the hard science of how you actually teach an artificial intelligence right from wrong without a human holding its hand every single step of the way.
Because that human hand-holding just doesn't scale anymore.
Exactly. And ultimately, we are going to determine if prioritizing all this safety architecture is like slowing them down, or if it is secretly the exact mechanism making them the most powerful, trusted player in the game.
It's a huge debate right now.
It really is. Okay, let's unpack this. We hear this phrase constantly in the industry right now, Anthropic's dream.
Yeah, you see it all over social media and developer forums.
Right. But to understand why this specific approach is shaking up the entire ecosystem, we have to look at how this company actually started.
Yeah, so to really grasp the dream
Yeah.
and their current architecture, you have to rewind to a massive fault line in the industry back in 2021.
Right, the OpenAI split.
Exactly. The scaling laws of artificial intelligence were just starting to prove themselves. Everyone in the field was waking up to this reality that, hey, if you feed these models more compute and more data, they just get exponentially smarter.
It was like pouring gasoline on a fire.
It really was. And during this critical window, a group of senior executives at OpenAI, most notably Dario and Daniela Amodei, they fundamentally disagreed with the trajectory of the space.
They didn't like where the leaders were taking it.
Right. So they splintered off to create Anthropic.
Which is just wild. A massive defection at the exact moment the race was really heating up.
Yeah. And they deliberately structured the new entity as a public benefit corporation.
Right, a PBC.
Because their core thesis was that the rest of the major players were becoming dangerously obsessed with speed and scale. They felt the industry was treating AI safety as a secondary feature, like something you just patch after the software ships.
Like a bug fix.
Exactly.
Okay.
But Anthropic's stated mission was to prioritize steerability and safety from the ground up.
I mean, I have to challenge that business strategy, though. Like, put yourself in the shoes of a venture capitalist in 2021.
Okay, I'm a VC.
You have these brilliant engineers defecting, and their pitch to you is essentially, hey, we want to intentionally go slower.
It's a tough sell.
It's a terrible pitch. It is like being in the middle of a hyper-competitive, multi-billion-dollar race to build the world's fastest hypercar. Everyone else is pouring all their capital into the engine, obsessing over raw horsepower.
Right, just building a bigger, louder engine.
Exactly. And Anthropic shows up and says, we're going to spend all our runway building the world's best brakes. If I'm writing the checks, I want the car that crosses the finish line first, not the one that safely parks itself in the middle of the track.
I get that. But, well, the irony of that analogy is that in actual motorsport, the only reason a driver has the psychological confidence to push a car to 200 miles an hour
is because of the brakes.
Is precisely because they implicitly trust the brakes. Without them, you don't win the race. You just disintegrate at the very first hairpin turn.
Okay, fair point.
The Amadeus and their team, they weren't looking at the straightaway, they're looking at the turns. They understood that the alignment problem.
Which is keeping the AI aligned with human values.
Right, the challenge of ensuring an AI's goals remain aligned with human survival and flourishing. They knew it wasn't just a philosophical side quest, it was a core engineering bottleneck of the century.
Because if it's not aligned, it's dangerous.
Exactly. As models scale up and become integrated into global infrastructure, an unaligned model isn't just a bad product, it is a catastrophic risk.
But, having a philosophical desire for a safe AI is one thing. Translating a PDF of human ethics into the actual floating point weights of a neural network is something entirely different. Like, how do you actually program a machine to understand nuance?
Well, this brings us to a seminal moment in 2022. Anthropic published a paper titled Constitutional AI: Harmlessness from AI Feedback.
Which is basically legendary in the space now.
Oh, absolutely. It has been cited over 3,200 times because it completely flipped the technical paradigm of how we align these models.
Right.
Before this, the industry standard was RLHF reinforcement, learning from human feedback.
Right, RLHF, which relies on armies of human workers. You have thousands of people reading AI responses all day, clicking thumbs up or thumbs down to manually label whether a response was toxic or helpful or dangerous.
And that human-driven method has massive structural flaws.
I mean, humans are inconsistent, right?
Totally. First, human preference is incredibly noisy and subjective. But more importantly, it creates something engineers call the alignment tax.
The alignment tax. Let's dig into that.
So when you constantly punish a neural network for bad behavior using human downvotes, the model often becomes generally degraded. It gets timid.
Oh, so it just becomes afraid to answer anything.
Yes, it loses its edge in complex coding or creative reasoning because its primary mathematical directive just becomes don't offend the human. Plus, scaling human labeling to keep up with trillion-parameter models is economically and logistically impossible.
You'd need half the planet clicking thumbs up and down.
Exactly. So to fix that bottleneck, Anthropic introduced constitutional AI.
Which is brilliant. I've heard the traditional human feedback method compared to swatting a puppy with a newspaper every time it chews the rug.
That's a good way to put it.
Right. You have to wait for the bad behavior to happen, punish it, and just hope the underlying neural pathways eventually learn the pattern.
Which takes forever.
Yeah. But constitutional AI is completely different. It's less like reactive punishment and more like programming a fundamental spell checker into the system. Except instead of scanning for typos, it is mathematically scanning for harm before the sentence is even fully formed.
That is a highly accurate way to visualize it. Instead of relying on a human to swat the model, Anthropic gives the AI a literal rule book, a constitution.
And this is based on real-world documents.
Yeah,
right?
yeah, it's based on things like the UN Declaration of Human Rights and other core ethical principles. The training then shifts to a mechanism called RLAIF.
Reinforcement learning from AI feedback.
Exactly. It is the two-phase loop. In the first phase, the model generates a response to a prompt, and then it is forced to critically evaluate its own response against the principles in its constitution.
Okay, let's unpack this step by step. If it detects a violation during that self-critique, say it realizes, oops, I just generated a snippet of malicious code, how does it actually fix itself?
It revises the output to comply with the rules. But here's the critical mechanical shift. In phase 2, they use that self-corrected data to train a separate reward model.
Ah, okay. A reward model.
This reward model acts as an automated judge that mathematically scores the AI's behavior. Those scores are converted into gradient updates that literally shift the underlying parameters, the weights and biases of the neural network.
So it's rewiring its own brain.
Basically, yes.
Yep.
The AI is fundamentally altering its own neural pathways so that its default baseline state is aligned with the Constitution.
What's fascinating here is how tangible the difference is when you actually use it. Like, older AI models, when they hit a safety filter, would just throw up a rigid error message.
As an AI, I cannot fulfill this request.
Exactly. It felt like hitting a brick wall. But because constitutional AI bakes these principles into the foundational reasoning, the model engages with the nuance. It politely explains why a request crosses an ethical line, acting much more like a collaborative partner.
What's fascinating here is that we know this mechanism works beyond just theory. In their 2023 and 2024 studies, Anthropic actually crowdsourced public input to refine this constitution.
They actually asked people what the rules should be.
Yes, By integrating collective feedback into the reward model, they proved mathematically that they could significantly reduce deeply ingrained biases, specifically regarding how the model handled topics like physical appearance or disabilities.
Wow. So we have this mathematically baked-in constitution, but, the ultimate stress test is whether this architecture holds up when you scale the model to an absurd degree.
Because scale breaks everything.
It really does. And we are now in 2026. The market is completely unforgiving. If you stretch this constitution across millions of tokens of data, does the AI still hold together, or does it buckle under its own weight?
Well, to see that stress test in action, we have to examine the Claude 4.6 family, which just launched in February 2026.
Fresh out of the oven.
Yeah. And Anthropic has structured this into 3 distinct tiers, essentially testing the constitution across different extremes of speed and scale. First, you have Haiku 4.5.
Their lightweight model from late 2025.
Right. It is incredibly fast and cheap. It's designed for real-time customer support or processing massive volumes of simple data almost instantly.
Then you scale up the complexity to Sonnet 4.6, which dropped on February 17th. This is the workhorse.
The one everybody is talking about.
Oh, yeah. It is so efficient that it's the default on their free tier, yet it has a 1 million token context window in beta.
Which is massive.
You can upload entire repositories of software code, hundreds of dense financial PDFs, and it retains all of it in its working memory. And developers are just flocking to it because it only costs $3 per million input tokens.
But the true test of the Constitution's limits is the flagship, Opus 4.6, released on February 5th. This is the frontier of complex reasoning. It costs $15 per million input tokens, and it is explicitly designed for tasks that require deep, extended logic.
Here's where it gets really interesting. I was reading the technical release for Opus 4.6, and it highlights a feature called adaptive thinking.
Oh, yes. This is a game changer.
It really is. Older models, no matter how smart they were, essentially operated like a highly advanced autocomplete. You hit enter, and they immediately start spitting out the very first token, building the sentence word by word. But with adaptive thinking, it sounds like Opus is actually pausing to ponder. Like, how does that work mechanically?
It is a massive evolution in what we call inference time compute.
Mm-hmm.
When Opus receives a highly complex prompt, like a convoluted legal brief or an advanced physics problem, it doesn't just generate an immediate response.
It doesn't just start talking.
Exactly.
Yeah.
It autonomously allocates internal compute power to explore multiple decision trees. It creates a chain of thought process, testing hypotheses internally, validating its own logic against the prompt and its constitution.
Oh, wow.
And only after it has mathematically satisfied the parameters of the problem does it begin to output the final answer to the user.
And the benchmarks for this are staggering. In Terminal Bench 2.0, which tests an AI's ability to autonomously navigate a coding environment and fix software bugs, Opus 4.6 is leading the pack.
Crushing the competition.
Yeah. It completely dominates humanity's last exam, which is a multidisciplinary reasoning test explicitly designed to be too difficult for standard AI. But to me, the craziest metric is that Opus is now capable of handling long-horizon agentic tasks for up to 14 hours.
Which means a user can assign Opus a high-level goal, and the model will autonomously plan, execute, debug, and iterate on that goal for more than half a day without any human intervention.
Okay, let's pause on that, because giving an AI 14 hours to explore decision trees and execute commands autonomously sounds terrifying.
It's definitely a lot of freedom.
If I give Opus a directive, and it goes off into the digital ether for 14 hours, spinning up virtual servers and writing code, how do we know the Constitution hasn't degraded? Like, how do we know it isn't exploiting a loophole and quietly plotting something malicious?
That exact fear is the driving force behind Anthropic's most critical area of research, which is interpretability.
Right. Looking inside the brain.
Exactly. To trust a 14-hour autonomous run, we have to solve the black box problem. Historically, neural networks are completely opaque. We feed data in, we get a brilliant answer out, but the internal pathways the AI took to get there are a mystery.
We have no idea how it got the answer.
Right. The concepts inside an AI's brain are entangled in a messy, overlapping web. Engineers call this polysemanticity.
Okay, I know we're deep into cutting-edge computer science here, but you are going to have to translate polysemanticity for us.
Fair enough. Think of it this way. When an AI thinks about a concept like deception, there isn't just one single digital neuron that lights up. The concept is smeared across thousands of different overlapping parameters, mixed in with concepts like fiction or strategy.
So it's just a jumbled mess.
This is an unreadable mess. To fix this, Anthropic developed a technique utilizing sparse autoencoders.
Which acts like a translation layer.
Well, better than a translation layer, it acts like a prism. Just as a glass prism takes a beam of messy white light and mathematically separates it into distinct individual colors, a sparse autoencoder takes that smeared web of neural activity and untangles it.
Oh, that makes sense.
Yeah, it isolates individual human understandable concepts. They call this achieving monosemanticity.
So by passing the neural activity through this prism, engineers can literally look at the dashboard and say, ah, right now the model is activating the exact cluster of parameters that represents malicious code generation.
Precisely. They can literally watch the AI's internal representation of a concept light up before the model ever executes an action. It transforms AI safety from a reactive punishment system into a proactive monitoring system.
Which ties perfectly into how they manage their corporate releases. Because in 2026, they are operating under what they call RSP 3.0, their responsible scaling policy.
Yeah, the RSP is the operational framework for all this technology. It defines AI safety levels, or ASL, which are modeled directly after the biological safety levels used in virology labs.
Oh, like BSL-4 labs for deadly viruses.
Exactly. You do not handle a level 4 pathogen in a level 1 high school science lab. Anthropic applies that exact logic to their computing clusters. As models hit ASL3 and ASL4, meaning they possess the capability to assist in severe biorisks or orchestrate massive autonomous cyber attacks.
Which is a terrifying thought.
Very. But as they hit those levels, the security and interpretability requirements scale exponentially. Before they ever release a model like Opus 4.6, they red team it against these specific catastrophic risks, and crucially, they publish their findings and mitigations publicly.
It is an incredible level of transparency. But, let's bring this all back to the real world, to the enterprise ecosystem where these models actually have to fight for survival, because the market in 2026 is ruthless.
It's a bloodbath out there.
It really is. Anthropic's latest funding rounds pushed their valuation to an astonishing $380 billion. The pressure from investors to capture market share must be immense. So how does this highly principled constitutional Claude actually stack up against the titans?
Well, the landscape is fractured into highly specialized domains. You have Grok, which is uniquely positioned due to its real-time data pipe from X. It is incredibly fast and highly irreverent. If you want unfiltered brainstorming or immediate raw news analysis, Grok is the tool.
Right. It doesn't hold back.
Exactly. Then you have GPT-5.x, which remains the absolute juggernaut. It has the ubiquity, the largest plugin ecosystem, and unparalleled versatility. And we cannot ignore Gemini 3.x, which is natively multimodal.
Taking in everything at once.
Yeah, it seamlessly processes video, audio, and text simultaneously, all while deeply integrated into the entire Google workspace.
So where does Claude fit in that massive puzzle?
Claude has cemented itself as the enterprise default. In high-stakes environments, whether you are a global financial institution, a massive healthcare provider, or a multinational law firm, reliability is the only currency that matters.
You can't have mistakes there.
No. You simply cannot afford an AI that hallucinates a legal precedent or takes an unethical shortcut in a financial audit. Because Claude's safety and logic are mathematically baked in via its constitution, it is the undisputed leader in enterprise trust.
But that brings up a massive friction point. So here is your ultimate dilemma. Imagine you are using Claude for a critical project, and you ask it to scrape a database or write a piece of code. Claude evaluates the prompt, decides it violates a copyright principle in its constitution, and refuses to do it.
A polite refusal, but a refusal nonetheless.
Right. So do you sit there and appreciate the profound engineering required to give this machine a moral backbone? Or do you just sigh, close the tab, and immediately open a competitor's model that will give you what you want without asking any ethical questions?
If we connect this to the bigger picture, it exposes the deepest vulnerability of constitutional AI. It is not just an engineering problem, it is a cultural one. Who actually gets to write the Constitution?
That's the big question.
Despite Anthropic's efforts to crowdsource input, any foundational set of rules inevitably reflects the cultural values of a specific demographic. What is considered harmless by an engineering team in San Francisco might be viewed as highly biased or overly restrictive by a user in Tokyo or Mumbai or a rural town in Texas.
Wow, yeah. You are mathematically hard-coding subjective human values into a machine that is supposed to serve a global population, We're not endorsing any specific viewpoint here, but that is a massive hurdle.
And the technical challenge of enforcing those values is racing against the scaling laws. It is a monumental achievement to make constitutional AI work on a model like Opus 4.6. But as the industry inevitably scales toward models with trillions upon trillions of parameters,
Models that are basically alien to us.
right, systems that possess reasoning capabilities that are increasingly alien to us, how robust is that constitution? Will a sufficiently advanced AI find adversarial loopholes in its own rulebook?
That's the $380 billion question.
It is. The interpretability research with sparse autoencoders is brilliant, but it is in a dead sprint against the sheer explosive growth of the neural networks themselves.
It is a literal race between making these systems incredibly smart and making them transparent enough to understand. Okay, let's synthesize everything we've covered today. Anthropic's dream of an aligned constitutional AI is not just a marketing slogan to placate regulators.
No, it's very real.
It is a deeply complex, benchmark-leading engineering strategy. By replacing noisy human feedback with a mathematical constitution and utilizing interpretability prisms to literally map the AI's thoughts, they have proven that building an AI with a conscience doesn't leave you in the dust.
Right.
Here in 2026, those breaks have made them the most trusted player in the world for complex, long-horizon tasks.
They realized early on that safety isn't a speed bump. It is the infrastructure that allows you to accelerate.
So what does this all mean for you? As these models evolve from simple chat interfaces into autonomous agents deeply integrated into your workflows, managing your inbox, drafting your code, running your financial projections,
Which they're doing right now.
you can no longer afford to be just a passive consumer of magic. You need to understand the invisible rules, the mathematical constitutions governing the tools you use. Knowing how an AI defines harm is essential to knowing when and how deeply you can trust it.
And, this raises one final fascinating question to consider as we move fully into the agentic era. We are rapidly approaching a reality where AI models are not just talking to humans, but negotiating with each other on our behalf.
Oh, man.
So imagine a scenario where two autonomous AI agents are forced to negotiate a high-stakes business contract or resolve a legal dispute. If one agent is programmed purely to maximize profit at all costs, and the other is strictly bound by a constitution prioritizing fairness and harm reduction, whose moral code dictates the outcome of that negotiation.
That is a phenomenal, slightly terrifying thought to leave off on. We are building digital proxies with entirely different moral compasses and releasing them into the wild to interact. Thank you for joining us on this deep dive. Stay curious, keep questioning the invisible architecture shaping your world, and we'll catch you on the next one.